Hello, ladies and gentlemen. Hope you are fine. This is mathematics. In this lesson, let's look at this question. This is coming from 2018 grade 12, paper 2, section A. This was question number 6A. The question, in the quadrilateral ABCD below, so we have a four-sided shape here, quad. We have A, B, C, D, in which the vector AB is equal to A. So we have vector AB is equal to M, vector AD is equal to B, vector BC is equal to 2B, and the ratio has also been provided, and that is A to E, or should we say AE to AC is equal to 1 to 3, okay? Now we have questions here. The first part says, find in terms of A and slash or B, the vector AE. We also have BE, BD. Then the last part says, hence or otherwise, show that the points BE and D are collinear. Okay? So the question, ladies and gentlemen, is coming from a topic called vectors in two dimension. How do you go about it? Well, whenever you are provided information with a diagram, make sure verify that the information which is here is also appearing on this diagram before you can start your calculations. So let's begin. We are told that in this four-sided shape, which is A, B, C, D, so we have A, B, C, D. The vector AB is equal to A. Verify that this is there. Okay, so from A to B, it is A. This is what we have been told here. Okay, so A is there. What else? AD is equal to B. Where is AD? AD is equal to B. So the vector has been provided. You can even see the direction. Vectors is about direction. So AB, you are able to see the direction here. AD, the direction is there. You see that? Further, they're saying BC is equal to 2B. B to C. I see that? B to C is equal to 2B. Then the ratio has also been given. This ratio, which is AE, okay, AE to AC is equal to 1 to 3. Now you have to understand the meaning of the ratio. And I must emphasize as well that the ratio is not always given in this format here. No. It can also be given in fraction. So don't say I did not tell you. When you see it in fractions, the application is the same. Whether it is written in this format or the fraction form, it is the same. How do you interpret this ratio here? That is now the question you need to ask yourself. So, AE will take the first number. Okay, that is the interpretation. So this one will take the first number, this one will take the second number. So from A to E, they are saying that is 1. So AE 1. Where is AE here? Okay, so we have AE. The ratio is 1. So you need to put a 1 there. Further, they are saying AC should take 3. So A to C. From this end to this, it should be 3. Now remember, you have 1 here. From A to E, you have 1. So E to C, what will remain? You agree with me that this will be a 2. See that? So that when I add 1 plus 2, I'll get a 3. That is A, C. That is what you need to know. Next, from there now, we will be able to start looking at the questions here. Find in terms of vector A and slash or B, AE. That is the first part. So we need to find the vector AE. Okay? Well, there are two major ways in which you will be finding vectors. One is by using the roots. Two is by using the ratio. What do I mean? AE. From A to E, imagine that this person is at this point A and you want to go to point B. You want to go to point E. From A to E. How are you going to move? One is through the root. And that route will be, you can either move it in this manner, from A to B, then B to E, that is one route. Another one would say, okay, I'll not be able to use this, I'll use another route. Say, okay, from A, remember you are here, this is the starting point, A. So this person will say, okay, from A to D, then D to C, then C to E. All of you will be able to find same answers with different routes. Now, how do you know the correct route that you are going to use? Of course, all the routes that you can use are correct and they'll give you correct answers. All of them. But you have to go for the route that has been provided with the vectors. Or in short, I'm saying you have to go for the route that has got the vectors. For example, I cannot use this route. A to D, D to C, C to E. Why? Because I don't know vector D, C. I've not been provided with that. Again, I don't know vector C to E. I don't know the vectors there. So that route cannot be used. Yes, it will give me correct answer, but I can't use it because vectors are not there. Let me check the other route. This one says A to B. Yes, I have the vector here. But do I have BE? I don't have. The information here is very clear. There is no BE. So that route again can't be used. In that case, what do? You think of the ratio. If roots here can't be used, then you think of what? Ratio. We have the ratio here, so it is this ratio that is going to give us the correct answer. Are we together? It is the ratio. Now we are going to apply the ratio. We are saying AE to AC is equal to 1, 2, 3. Now, get me very well here. AE will take the first number. I'm now changing from ratio to vectors, so to say. So AE 1 over the total. So AE will take this one out of the total AC. So the total from here to there is what? Is 3. So out of the total 3. And this 3 is vector AC. That is how you change from ratio here to vector form. Are we together? So when you are changing AE, first number that represents AE over the total, then this total as a vector AC. Then we are now going to replace where there is AC. We find the vector. So we're going to say AE will be equal to 1 over 3. What is AC? Let's check in the diagram here. Do we have AC? From A to C. We don't have, but we can find. We can use this route. A, B, B, C. We'll get AC. Because I've got this vector, I've got this vector. Of course, there is another route here, but I don't have B, C. I hope you are getting me. So you use the routes that have got vectors. A to C will be A, B, B, C. I'll be there. I can also use A, D, D, C. It will still be the same answer. But I don't have this, so I can't use this route. Okay? Right, so we are going to leave this here, and then we need to find AC. So we're going to say, well, AC will be equal to So A to C will be AB plus BC. This is what we call vector addition. So always the first letter here will be the first one here. And the last letter here will be the last one here. I see that. Then you are going to say AC will be equal to, we substituting here. What is AB? From A to B, they've said A, vector A, plus BC, BC is to B, like this. That is AC. This is the answer. You cannot add these because they are not like terms. This is A, this is B. So this is our AC here, which we are going to substitute here. A plus C to B. I see that? So meaning this is now our final answer. Of course, some would want to expand this. There's no problem. If you leave it here, full marks again. No problem. But if you want to expand, you can still say AE, okay? AE is equal to 1 over 3 times A, it will be 1 over 3A plus 1 over 3 times 2, B, it will be 2 over 3B. So that will still be the same answer, whether you get it this way or this way. As you're underlining, some of you, I know you like underlining, but my caution to you, whenever you are dealing with vectors, is these vectors must be well shown. They must be there, visible, so to say. Not whereby you want to underline these, okay? Let's say I want to underline A, vector A plus 2B. You see, if you want to underline it like this, no problem. Not whereby you do this. You have cancelled the vectors, and that is wrong. Okay? So you can do it that way. We proceed to the next question here, which is BE. They want us to find BE. Well, you are going to write, so this was our first one, second one here. BE, okay? So our BE will be, we come to the diagram here. Where is B? We have B here, we have E here. I see that. How are you going to move? You are at this point B, you want to be there. Well, you are going to say from B to E, let me write here. So we want to find BE, vector BE is equal to. So from B to E, I can either use this route, but I have to check the one that has got E vectors. Well, I'll be able to say from B to E, I'll move B to A. I've seen that. So it will be B to A. From there, A to E. A to E. I've used this route because I know that I have BA, I also have E. I cannot use this one because I only have BC. I don't have CE. There's only a ratio here, not a vector. So I can't use this route. Okay? Then we substitute in here. We are going to say BE will be equal to, what is our BA? Now, listen very well. I said vectors is about directions, right? What we have here is A to B. Look at the arrow. A to B, which is A. Now, in a case whereby same letters but different direction, B to A, it means this one will take a negative. Since it is positive here, it will take a what? A negative. They're in different direction. So if A, B is A, then B, A will be negative A. So we have negative A here. Plus, what about AE? AE, it's the one that we are from calculating here. AE. Have you seen that? AE. So AE is here, the one that we expanded. So it will be 1 over 3A plus 2 over 3B. Did you know where we got the 2 over 3? We multiplied 1 over 3 times 2. 1 over 3 times 2. It means over 1 here. 1 times 2 is 2. 3 times 1 is 3. That is where we got that from. Then, our final answer here will now be BE will be equal to, these two are like terms, so you cannot leave them like this. No. Remember, find in terms of A and slash or B. So you can't leave two same vectors in the answer. No, it doesn't work like that. So these two must be simplified. What number is here? When we say negative A, vector A, what number is here? There's a 1. So in short, we have negative 1 here. Negative 1 plus 1 over 3, like this. Then find the answer to this. This is a fraction, make this a fraction as well. Then you're going to say negative 1 times 3. That is the short way. Instead of saying common denominator 3, what and what, you just say negative 1 times 3. It will be negative 3 plus 1 times 1. It will be 1 over 1 times 3. It will be 3. Then negative 3 plus 1 will give you negative 2 over 3. So negative 2 over 3 is the answer to this. So we have negative 2 over 3 A, vector A. Then plus 2 over 3 B. Are we together there? So that will be the final answer. You can leave it at this stage, or if you want, you can start with the one that has got a positive. So you can say BE is equal to the one that has got a positive, so that this one goes inside. So we're going to say 2 over 3B minus 2 over 3A. You can now leave it at that stage. This is the correct answer for BE. We move on. We have BD. That's the next one. Okay. BD, vector BD. We go back to the diagram. Where is BD? B to D. I see that? B to D. So here there's no line. You can still extend a line. There's no problem. Like that. B to D. How are you going to move? You can say B, C, C, D. That will be correct. But remember, you have to use the roots that have got vectors. So I'm not going to use this one because I don't know C, D. I'm going to use this one, B, A, D, because I've got these roots. So my BD, remember the starting point is B, so it will be B, A, plus C, A, D. So plus A, D, like this. Then we substitute the vectors here. So it will be BD will be equal to, what is BA? Again, this is opposite vector. BA meaning to be negative. So it will be negative A plus C. What is A? D. From A to D is vector B. So this will be vector B. That will be the answer. But again, you can start with the one that has got a positive. So you can say BD is equal to, the one with positive is this one. So you can say B minus A. That's the end. Just like that. So that is the answer for that. Well, the final question here says, hence or otherwise, show that the points B, E, and D are collinear. Now you have to understand the meaning of the word collinear. What is colinearity? When you are dealing with coordinate geometry, collinear there means points that have got same gradient. That is collinear. They are collinear. If points have got same gradient, we say they are collinear. But when it comes to vectors, the application of collinear is about you showing the marker that these points are in the same straight line. That is collinear. Okay? So we want to show if B, E, and D are in the same straight line. Come to the diagram. B, E, and D. We want to show that these 3 points are in the same straight line. That is collinear. If we are able to show, then we conclude that the 3 points are collinear. The question is, how do you show mathematically? How do you show that these 3 points are collinear or are in the same straight line? There are different methods that you can use, but I feel this method is okay. Well, you can say you need to, so we are on the last part. So this was supposed to be B, this was C, okay, then the last part here. For us to show that the 3 points are collinear, then we are saying B, D, vector BD should be equal to, are you getting me? For you to show that BED are collinear, then this length from B to D should be equal to a certain number, which I can say H, that will be regarded as the scalar. So you can use any letter here. So we are saying, for these 3 points to be collinear, then B to D should be multiplied by a certain number, which I would just be able to say H, B, E, B, E. In short, I'm saying, if this statement will be true, if we'll be able to find H here, then we'll be able to conclude that the 3 points are collinear. If we are not going to find H, then they are not collinear. Okay? This statement, I'm saying, for the points to be collinear, these 3 points to be collinear, then this length BE, BD must be multiplied by a certain number. You multiply it with a BE. Of course, it can be expressed in, this is not the only way you can express it. You can express it different ways. You can even say, for the points to be collinear, then BE must be multiplied by a certain number to get BD. You can express it in that way. Is the condition clear here? This is the condition. For the points to be collinear here, then BD must be multiplied by a certain number by BE. So BE is equal to any number BE. Then they are collinear. So here now you just substitute to get H. What is BD? We have BD here. Okay? BD, which is this. So I'll substitute there. B minus A, like this, is equal to H. I want H here. What is BE? We got B here. Are we together? That is BE, which is 2 over 3 B minus 2 over 3 A. Have you seen the substitution there? Then this side we can expand. Okay, we can expand. When we expand, we are going to have BE minus A is equal to H times 2 over 3B. This is the way you should write in vectors. You start with a number, 2 over 3, like this, followed by this. Vector should always be the last thing, like this. Minus, again, H times this will give us this 2 over 3, H, then vector A. At this point, I can equate so that I have the value of H. B and B, A and A, you can just pick one. So I'll say B, here, what is here is a 1, okay? So I've got B here, which will be equated to, I have this one here, which is 2 over 3 HB, like this. How do we get H? I will be able to say BB, this can be cancelled. So when I cancel them, I'll remain with a 1 here. Agreed? So I have a 1 here. The B's will go, is equal to 2 over 3 H. For me to remain with H, I have to get rid of this. Are we together? I have to get rid of the 2 over 3. Meaning, I have to multiply by 3 over 2. Even this side, 3 over 2. Then I can cancel everything here, and my H will now be equal to 3 over 2. I see that? 3 over 2. Now I have found the value of H. I can safely say, or substitute here, where I'll be able to say BD is equal to H, that is 3 over 2. What is BE? Which is this one. H here, 3 over 2. Then I've got this vector BE, which is here, 2 over 3 B minus 2 over 3 A. I've substituted. This is the value of H. At this point, you have satisfied the condition for colinearity. Whenever you find the value of H here, it means you have satisfied the condition. And this tells you that the points are collinear. As long as you find the value of H here, then they are collinear. Even here, you can substitute, which is this one here. Isn't that? That is collinear. You can simply say, therefore, the points B, E, and D at this point, and what? D are collinear. Like that. First of all. Of course, this is not the only method. The other method that you can show is when you factorize here,